Good morning everyone, my name is Charujan and today we are going to discuss Kirchhoff voltage law numerical. Okay, so basically Kirchhoff voltage law have given two methods for solving numerical. One method is by branch current method, which we had discussed in our previous video. Okay, and another method is loop current method. So I am doing for you the same question by both the methods, so that you can get differentiate between these two. Okay, so first I am solving this simple question by a branch current method. Okay, so I told you according to the steps, move to step number 1. Step number 1 is the mark current direction, right? We need to mark current direction. For that we need to see that how many meshes are there, correct? So in this, how many meshes are there? If we'll see, this is a whole house, and how many rooms in this house? 1 2 3, means there are 3 meshes. Okay, 3 mesh means how many variable? 3 variable. And what are those variables? That is I1, I2 and I3. And 3 variables means you need to solve 3 equations, then only you will get the value of I1, I2 and I3. Okay, now let's start. Suppose I am marking this current in a branch. Branch means wire. Okay, I am marking this current in a wire. In this case, suppose current is leaving the battery and we have marked I1. Now in this you need to study this thing also, that till now you had studied that current always leaving potential terminal and entering into a negative terminal, positive to negative, right? Higher potential to lower potential. But for now that is not compulsory for you that you have to mark the current like that only, that current is leaving the positive terminal and entering into negative terminal. You can mark it opposite also. You will get the answer of current in negative direction, but that is also not wrong. Okay, so I am taking this current is I1. Okay, this is the node. As I told you, from the node current splits, and I am taking, suppose here I2 current is flowing. Okay, now tell me how much is the current flowing in the 6 ohm branch? That is I1 is the incoming current, so it would be positive, and I2 is leaving the node, right? I2 is leaving the node, so it would be negative. I1 minus I2. Now again there is a node, we can take up to 3 variables, so third variable we can take, that is I3. Now okay, now in the 5 ohm branch how much current can be flow? I1 minus I2 is the incoming current, so I am considering it as positive, that is it is entering in a node, and I3 is leaving the node, so leaving the node means negative. Okay, if it is entering in a node, just write down, if it is entering in a node then it would be marked as positive, and if it is leaving the node then it is marked as negative. Okay, clear? So our first step is complete, that is mark current direction. Now move to step number 2. Step number 2 is, that is mark sign convention, right? Mark sign convention. We need to mark sign convention, means we need to mark sign. I'm marking sign here. It would be like current is moving from A to B, so here it would be positive, negative. Battery big one is positive, negative. There is no change in sign of battery with respect to current. Okay, now current is moving from, suppose B to C, marked here positive, negative, then B to E, positive, negative, then E to F, positive, negative. Okay, then E to G, suppose positive, negative, because current is moving from positive to negative. Okay, where from which node current is leaving, that is positive, and from which it is entering, it is negative. Okay, so big battery will remain same, big one positive and small one negative. Our second step is also completed. Next is step number 3, that we have to apply KVL in mesh 1. Okay, we need to apply KVL in mesh 1. And how can we apply KVL in mesh 1? As I told you in the last lecture that we are at A position, right? And we need to back to the A position. You are moving from A to B, B to C, C to D, then back D to A, right? I told you na, this is your home to college, college to gym to shopping, and shopping back to home, right? So whatever comes in your whatever comes in your path second sign, you have to take that. So you are moving from A to B. What is the second sign comes in your path? That is negative. So you will mark negative. Resistance is how much? 2 ohm. Current is how much? I1. Okay. Now you are moving from B to C. What is the second sign coming in your path? Again, I'm saying that you are moving, not current is moving. Just leave that current. Now you are moving from A to B, B to C, C to D, and back to A. Okay. So you are moving from B to A. What is the second sign coming in your path? That is negative 4 resistance, and current is how much? I2. C to D, there is nothing, leave that. D to A, then plus 10 is equal to 0. So this we got the equation, that is we have applied KVL in mesh 1. Okay. Next step, we need to apply KVL in mesh 2, right? We need to apply KVL in mesh 2. Mesh 2 is which one? B, E, F, C. You can mark, like write down here also, B, E, F, C, A, B, C, D, right? So you are moving from B to A. Again you need to take second sign, minus 6. And how much is the current flowing in the 6 ohm branch? That is I1 minus I2. Okay. Now you are moving from E to F, right? You need to take second sign, that is minus 10. How much current? I3. F to C, nothing is there, leave that. C to F, what is the second sign coming in your path? That is plus. So it would be like plus 4, and current is how much? I2 is equal to 0. So this you got as a second equation. Clear? Now you need to apply KVL in mesh 3, right? Mesh 3 is which one? E, G, H, F. Okay, I'm writing down here E, G, H, F. Again you need to do the same thing. E to G, that is negative, resistance is 5. How much is the current flowing? That is I1 minus I2 minus I3. Then G to H, that is minus 20. H to F, nothing is there, leave that. F to E, okay, then it would be plus 10. I3 is equal to 0. That is the third equation. Okay, so now what you need? You are having 3 mesh, 3 variable, and you got this 3 equation. You can solve this equation, okay, manually also, and you can solve this equation with the help of calculator also, with the help of fx991ms or any number with es or ex. Okay, these equations cannot be solved in the calculator 100 ms. Okay, it cannot be solved in 82 ms. So for solving this equation you need to buy these calculator. Okay, bring your calculator. I'll tell you how to solve this equation in your calculator in the next video. So you don't need to do it manually, because now your brain need to focus on making this equation now, not to solving this equation. Okay, now I hope you can solve this equation. Okay, and in this what they have said, you have to determine the current in 6 ohm branch. Now tell me how much is the current flowing in 6 ohm branch? That is I1 minus I2. Okay, so after solving this equation you will get the value of I1, right? You will get the value of I2, right? And you will get the value of I3, correct? Now you can solve this equation and you will get the value in 6 ohm. 6 ohm, how much is the current flowing in 6 ohm? That is I1 minus I2. You can put this value I1 minus I2, then you will get it accordingly. Clear? So this was the method we had done for the branch current method. Now we will do the same question by loop current method. Okay, loop is like a mesh, as I told you. In this we will mark current in a different way. Now again we will follow the steps. Step number 1 is to mark current. I am solving the same question by 2 different methods. These are the 2 different methods given by KVL only. Okay, that was the branch current method, in which I have marked the current in branch. This is the loop current method. In this I'll mark the current in the loop, complete loop. Suppose this one is A, B, C, D, E, F, G, H, right? Now how many meshes are there? As you know that there are three meshes. Okay, three meshes means you can take three variables. Three variables means you can take I1, I2 and I3, right? Now suppose, just imagine you are there. Okay, this is I1 room. As I told you now, this is your house, right? And your house, how many rooms are there? Three rooms. So only three people are allowed to live in this, right? So this is the room of suppose I1. Okay, this is the room of suppose I2. Okay, and this is the room of suppose I3. Clear? Now they are all moving in which direction? Clockwise direction. It's their choice. They can move in anti-clockwise also, right? They can move anyone in anti-clockwise direction also, or they can move like two clockwise and third one is anti-clockwise. It's your choice now that how you are moving in your house, whether you are moving in clockwise or in anti-clockwise. It totally depends on your choice, right? Clear? So I have marked in a simple way that all the three are moving in a clockwise direction. Clear? Next, step number 2. What was the step number 2? Tell me. If you have seen the previous video, you would know about it. Step number 2 is mark sign convention. Sign convention means you need to mark sign, right? So now according to this, your current is moving from A to B. Like just imagine you are there. Okay, not current is there. I1 is the you only, and your room is there. Your room is A, B, C, D, D to A. Now you are seeing your room. You are moving from A to B. Okay, you are in the room and you are moving from A to B. Then positive, negative, right? You are moving from B to C. Then mark here positive, negative, because you are going from positive terminal to negative terminal. Okay, C to D, nothing is there, leave that. Battery, big one is positive and small one is negative. Okay, now I have marked in mesh 1. Now similarly I2 is your friend. Okay, and I2 is your friend and he is also moving like you only. He is moving from B to A. Then mark positive here, negative, positive, negative, positive, negative, right? He is moving from C to B, but you are moving from B to C. You totally move in the opposite direction according to the middle one branch, right? Now again I3 is your third friend. He is moving from E to G, that positive, negative. Battery will sign will remain same. He is moving from F to E, that positive here and negative here. Clear? I hope it would be clear to you all this sign convention. See, I have marked different sign in the middle one branch, B to C. This is the middle you can say wall, right? This is the middle wall, and in this you are moving from B to C, but your friend is moving from C to B, right? Again, this is a middle wall between these two rooms, right? So you are moving, your friend is moving from E to F and your another friend is moving from F to E. Both are moving in the opposite direction. Clear? If both are moving in the opposite direction, then that would be negative. See, I'll tell you. Like suppose this one is A, this one is B, this one is C. Okay, you are the I1 and you are moving from up to down, right? So you will mark here positive and you will mark here negative, and you are I1, right? And your friend is there, but your friend is moving from down to up, right? Your friend is there across the middle wall and your friend is moving from down to up. He is moving down to up means then we will mark positive here, negative here. Means you both are moving in the opposite direction. Correct? You both are moving in the opposite direction. So accordingly, if it is in your room, then you will mark I1 minus I2 because you will be positive. If it is in your friend room, then that will be mark I2 minus I1. Okay. If it's I1 room, then I1 will be positive, other will be negative. If it's I2 room, I2 will be positive and other will be negative. Clear? So we will apply this concept, okay, in this mesh, in this Kirchhoff voltage law. See, if you are moving in the opposite direction, if currents are moving in the opposite direction, then current would be subtracted, okay. And if currents are moving in the same direction, then current would be added. Like suppose this one is B, this one is C, okay, again I am saying that your friend is moving from up to down, then positive here, negative here, and your another friend is moving from down to up, then positive here. Sorry, I need to take same direction now. Your another friend is also moving from up to down, right? You are also moving from up to down, your friend is also moving from up to down, then you will mark positive here and negative here. Okay, then both are moving in the same direction, then you both current will be added. In this case also I1 plus I2, and in this case also I2 plus I1. Clear? So now I am marking this. I have completed my step 1, that is mark current direction. Now I have completed step number 2, that is mark sign convention, right? Now I need to apply KVL in all the 3 meshes. Clear? Now we will take mesh 1. We will take the equation for mesh 1. Now tell me what would be the equation of mesh 1. Again you are moving at you are standing at A position, A to B, B to C, C to D, D to A, right? Now tell me, if you are moving from A to B, what is the second sign comes in your path? That is minus. Resistance is how much? 2. Current is how much? How much current is flowing from A to B? That is I1. Okay, now next you are moving from B to C, then second sign is negative. Resistance is how much? 4. And you are moving from B to C. Okay, as I told you, this is the middle wall. In the middle wall both the friends are moving. You are moving from B to C, but your friend is moving from C to B, and you both are moving in opposite direction. If I'll take your mesh, then that you would be positive and another would be negative. Then in that case it would be I1 minus I2. Okay, if I have taken mesh 1, then I1 minus I2, and if I have taken mesh 2, then in that case I2 minus I1, because both are moving in the opposite direction. Opposite direction means subtraction and same direction means addition. You can write down here opposite direction. In this case there is a opposite direction, then there is a subtraction. Okay, and in this case there is a same direction, because both are moving in the same direction, then that would be, there would be addition. Okay, how will you detect that whether it is in opposite direction? By the sign. If signs are opposite, then means both, that means both are moving in the opposite direction, then you would subtract with each other. If signs are same, then both the currents are moving in the same direction, then you will add with each other. Okay, so it would be minus 4 I1 minus I2, C to D nothing is there, D to A back, plus 10 is equal to 0. So this is your equation of mesh 1. Now tell me, now you're going to tell me that what would be the equation for mesh 2. You are standing at B position, moving from B to E, E to F, F to C, and C to B. So B to E, what is the second sign? Again negative. Resistance is how much? 6 ohm. Current is how much? I2, because in this I2, see I2 is flowing, right? Next again E to F, second sign is negative. Resistance is how much? 10 ohm, and you are moving from E to D. Okay, opposite sign means opposite means both the currents subtract with each other. So if you are taken I2 mesh, then I2 would be positive and I3 would be negative. F to C nothing is there, leave that. C to B, what is the second sign? Negative. Resistance is 4. Now again both are in opposite direction, so it would be I2 minus I1. Okay, because I2 is moving like this and I1 is moving like this. So if it is in the room of I2, I2 would be positive and others would be negative. So this will get the equation 2. Similarly, we'll get the equation 3 for the mesh 3. You are moving from E to G, that is minus 5. Current is how much? I3. Then G to H, minus second sign 20. H to F is nothing. Then D to E, second sign is minus 10. Resistance is how much? I3 minus I2 is equal to 0. And this also it is equal to 0. Now you got 3 equation, 3 variables, right? You got 3 equation, 3 variable. You can solve it and then you will get the value of I1, you will get the value of I2 and you will get the value of I3. I hope it would be understood to you. Okay, in case of any doubt, you can contact me on my number or on my Gmail ID. Thank you.